6:30 on Friday, March 18th. Happy belated St. Patrick's Day to everybody out there. But this week's code of conduct to work in an environmental conscientious manner. It's a very important code item for us. Mr. Dow, is there any other action items you would like to discuss?
Take care where we live.
Yeah, well said. Yeah. Another 7 days without a recordable injury. Excellent job this week. Again, our exposures are going to be going up as spring is slowly trickling. We're not quite there yet, but again, with these changing conditions, making sure that we're communicating our hazards, knowing our risks, making sure they're calculated and communicated across all lines of all employees. So let's keep up the good work, and everybody after this meeting, let's get on our JHAs and get them started for the day. This week I wanted to highlight our occupation noise exposure. We have quite a bit of it in the type of work that we do. Here's an example of some pile driving, very noisy environment. Same thing with a lot of our other type of pneumatic tools that we use and electric tools that we use. So I just kind of want to highlight on the preventing of hearing loss. The biggest thing is, again, is identifying that exposure. And the rule of thumb is 85 decibels or greater for an 8-hour day is when we start seeing signs of hearing loss. So there's a couple different tools to help us identify those. Is just right on your smartphones. There's an app called Sound Meter. It's a really good app to have to do quick checks. And then if you want more occupational study and industrial hygienists, we actually do have an integrated sound level meter here at Health and Safety. So if you want to actually get a good reading, contact myself. I'll come out and do a little survey on the job site. I got a little graph here that kind of shows the thermometer of noise, and as you can see, an electric drill is about 94 decibels. So you could have hearing damage with using electric drill in about an hour. Garbage disposal is 91. Hearing damage at 4 hours from lawnmowers, things like that. So, once we get into that like threshold of pain, that's kind of that fire alarm and firecrackers that could be extremely noisy. That's about 125. And then, yeah, I think we have a lot of people that shoot firearms. That's about 140 decibels. So it's very important if you're out shooting, you always wear hearing protection in those kind of atmospheres. So it's very important that you kind of identify, throw on those PPE. And again, with all of our safe work practices, we try to follow that hierarchy of control. So again, we try to eliminate the noise if possible. A lot of times we can't do that. Try to find alternative equipment and tools. We try to do that sometimes, during night shift operations where we put the mufflers on our backup alarms. Some other engineering controls that we could try to do is noise suppression on equipment, barriers, and enclosures. Other administrative controls that we can do, it again, that's just signs and strategic placement of loud equipment. Try to keep people away from those noisy equipment if they don't need to be there. And then again, in that last line of defense with noise is using our reusable earplugs and earmuffs, and those are all located down in the tool crib. So just make sure you're well stocked up for this upcoming construction season with the type of equipment you need to making sure that no one suffers any hearing loss while working on the projects. With that said, that's all I have. Ken, feel free to jump in if you have anything to add.
I think that sometimes it's just a matter of having it handy, the hearing protection handy, and having, some in your pocket. I end up sometimes after I use them, I stick them in my little side pocket there, and they go through the wash, and I'm like, oh, I need some. Here they are.
Yeah.
And they're all clean.
Yeah, exactly.
So let's see. I'm going to take over for now. No.
I'll just chime in real quick, Ken, if I can, while you're switching over.
Go ahead.
The one thing to remember about the decibel scale is it's not a linear scale. So if you're exposed to something that's, say, 110 decibels, that's dramatically louder than something that's 100 decibels. So You might look at it and say, wow, gunshot's only 140. Well, that's, that has the ability to cause a lot more hearing damage than something that's even, 130. So keep that in mind.
Right. Yep. It creeps up fast and it's got a lot of energy in it. Oops, okay. I can steady my mouse here. So no new announcements. Just a reminder again, insurance cards are in. I don't know if all those have been used up, and there might be some fuel cards. I'll check with Sarah next week to see if there's still some fuel cards. If there are, we'll probably try to track people down. Last week we talked about the primary care wellness program with Beth from Champlain Medical, and I urge everyone to get enrolled in the program because there's a lot of benefit to it. And Spring Arrives Sunday, along with it, of course, some showers. And the policies, COVID policies, the good news is that Williston officially lifted the mask mandates. So presumably going to some of our vendors in Williston will mean that we don't have to wear, the mask in their facilities, in the public facilities. And I'm going to turn it over to Brad. Brad, do you want to take control of the screen? Or you want me to just scroll down?
You can scroll, Ken. That'll work.
Okay. Well, go ahead.
All right. So VTrans St. Johnsbury WCRL 24. It's located on the Washington County Railroad, and it's bridge 538. So ECI is contracted with VTrans to rehabilitate the existing through truss bridge number 528 over the Sunset River.
I made narrative.
Yeah.
538, right?
Yes.
I'm pretty certain.
538. Yep.
Doesn't matter much.
The steel repairs included truss bottom cord repairs, floor beam web repair plates, stringer web repair plates, stringer bottom flange cover plates, lacing bar replacements, and full replacement of approach base stringers on the southern span. The rehab included 20 square yards of Class 2 concrete repairs on the span 2 southern abutment. The structural steel work included 13,200 pounds of structural steel repair pieces. And the interesting thing is, like, the largest one was about 280 pounds. So it's a lot of plates to make up 13,000 pounds.
Mm-hmm.
4,280 pounds of rolled beam stringer replacement and 2,300 rivet replacements with high strength bolts. Work started in August with our surface preparation contractor installing the suspended platform, which was used for lead abatement, sandblasting, and later the installation of steel. Unlike previous railroad projects, the southern span of this bridge is located under Interstate 91 and posed a safety risk during snow removal this winter. To maximize the working days, the crew focused on the southern span during fair weather and moved to the north when I-91 was being maintained by the district. Surprisingly, or not surprisingly, a majority of the steel repairs were located on the southern span, which experienced significantly more rust and salt exposure from the interstate overpass. ECI is awaiting favorable weather to return and complete the small amount of steel installation and concrete repairs. And it looks like next week is that favorable weather, so we'll be headed back. So this is taken from the man lift on the southern end looking north. So
Pretty cool
you're about right under. Yeah, it's rare that I have a man lift and I go up that high for the photos. But that's the southern span. You can kind of just see all the rot and deterioration going on.
Trying to get down there without my screen jumping around. There we go.
So that's the elevation of the two spans, and
so I think
pretty
this
much
is
set up all our staging in the south.
This is a Pratt truss, it's called, I believe. Very simple design. It looks kind of nice. I like the style of it.
Yeah, it is much simpler than like the pin truss we worked on 2 years ago now.
Brad, I'll add, and maybe you can speak to it, but one thing that we've experienced we've done a lot of these now is really high quality of workmanship and fabrication on a lot of these old turn of the century bridges. This bridge was probably an exception to that theme. The alignment, the fit up, especially between multiple plies of steel and the holes in the rivets, wasn't great, which caused the guys a lot harder time just removing rivets and fitting things up with misalignment and oblong holes.
Yeah, what we presume are some more field-made connections have more misalignment than we've seen before, and just a curveball that's thrown at you. You don't know until the rivets are out.
So are the Passumpsic River.
I haven't seen many fish.
No,
No.
I think the upper section in St. Johnsbury and above. So those lines on the left side are the interstate above, I-91 above, northbound, southbound.
So that's a bottom chord section there, and you can just see that the heavy rust and scaling that's happened. That's not typical of other bridges that we see where it's mostly just a water and age. That this is really showing the salt deterioration. Lacing bars almost rusted through. So here you can see a bottom built up chord section, which was made up of a 6x3 angle or a 4x3 angle, I believe it was. And it's just paper thin at the edges and a high amount of pack rust between the web plate and that vertical angle leg. Made it challenging just to remove existing rivets without damaging the bridge more than your repair can fix.
How do the pieces come off once the rivets are removed? Since it's kind of caked with rust, do they stick pretty good?
Some of them do stick pretty good. The lead abatement contractor did a really good job sandblasting for us to help with the rivet removal process. But some of the plates, when you open up the plies, just that caked in pack rust separates, and it was an added step to make the final connection, good and strong. That's a floor beam connection there to the outside truss, and you just see a lot of rough scale and corrosion going on. So there's a lot of repairs in those typical connections where the salt and the snow was sitting from prolonged exposure to the I-91 plowing. That's the top side truss. That's a strut between the two cords. The circles are rivet replacement items, which those are very challenging when the heads are that rotten. The material around it is rotten to get the flame cut to work right and to punch things out cleanly and efficiently.
Yeah, it looks pretty nasty.
Yeah. So here the guys are doing some rivet removal, wearing their Papper helmets for the lead exposure, and that's Dale and Luke Jerome there. So there was roughly 2,500 rivets needed to be removed just for the steel installation component.
Wow. Of challenging rivets.
Yes, especially lacing bars. They're tricky. So here you can see what the repair was: a perforated 3/8 thick plate, hot dip galvanized, and that replaced the lacing bars. And here the guys are torquing those to 41,000 pounds of tension using an electric torque gun.
Yep, cool.
These plates were generally batch filled in the field to any existing pattern to ensure accuracy and speed up production. This is the replacement of the 2 southern approach stringers. This process actually went really well. It's simple when you don't have floor beam on either side, but the guys did really good at this. We've done quite a few of them now. It's pretty easy in and out. And Lee's crew came in and panelized the track for us the day before, so we could take off that bay at once, and then dapped the ties for a wider stringer flange width, and then put it back on, and train went through later that day.
So there are different widths on the flange from the original because they're built
Yeah.
up, the rolled sections versus built up.
Yeah, we had to widen the daps by 1 1/8 inches based on the new material availability.
Okay.
So it was pretty simple dap, but yeah, it was a little bit more we had to do for it.
Yep.
And here the guys are doing rivet removal on the top cord section, and they're very adamant about not putting debris into the river. So we did what we could to close the band lift and catch all that pack rust falling off as we hammered it. But it's a good shot. You can see the I-91 over top of us, and that's where the snow problem came into play.
So they kept that section of plate there, I guess, huh?
Yeah, so we really just spliced over and cover plated things. We didn't remove too many existing
I see.
plates. So we came in, removed all the rivets, put in temporary bolts, so that later we could just do our wire wheeling and then match drill the steel to the existing patterns.
It almost seems like they should put a filler material in there, doesn't it?
It's funny you say that, Ken. The Sharon project has began incorporating what they call bearing compound, and it is a tricky item to deal with. It's labor intensive, and it's kind of like drywall. You can only build it up so much, and then you got to sand it smooth and reapply it to a smooth bearing surface. And I'm happy on the railroad bridges we're not doing that yet.
Yeah. But I can see the advantage if you fill up gaps that would otherwise fill with moisture and probably salts in this case.
Agreed. It definitely would prolong the life of the bridge. Here you can see there's directly in the front of this photo is a floor beam web repair where you're splicing the bottom angle into the web to span the rust, and I think that one actually had a hole through the web. And then on the right side is a stringer cover plate repair. This is a upper cord lacing bar replacement. I was taking a photo for the inspector that all the DTIs have been tensioned. You can see that orange media by the washers, and that's indicating you have full tension in the bolt.
I can really imagine how challenging it is to remove the rivet, like in that far corner where the new bolt is.
We had some challenges there and different tooling we used to get everything we had to. That's just a full stringer cover plate repair on the bottom, and then a web repair plate on the vertical face.
That was it. And then we have from the archives, this is January 2008 on the North Hero Grand Isle drawbridge, some steel repairs. a little bit different, but it looks like cold weather, you know, galvanized steel attaching to old steel. So looks like rivets
Is
on
that
that project too.
And a maybe bridge across the top of,
Yeah,
The other
that was,
bridge?
yep, that's correct. So now, of course, it's all been being replaced by Chinbro up at the, you know, where the drawbridge is. They're putting in, they had a temporary, right? And now they're putting in a replacement. So pretty big job up there. All right, that's all we got. Thank you very much, Brad. That was a great, you know, presentation on your project, and it looks like the guy's been working really hard and on some challenging conditions there. So
thanks, Ken.
I'll turn it back over to Matt. Have a good day out there, everybody. Be safe, and looks like we got some milder weather, so mud season is here.
Yep. Thank you, Ken. Thank you, Brad. For all that watched in a kind of a group setting, I've already seen a couple of text messages come through. I appreciate it, but let's try to capture attendance. So continue emailing or texting ones that watched it together so we can get attendance. Let's be safe today. Let's have a good day.
Okay, see you later.